right. Phew, finally. All right, welcome. Hi, everybody. It's the Keshe Plasma Reactor group for Tuesday, August 1st, 2017. World Peace Day. Woo-wee! So it's the declaration of world peace for humanity. We're having the signing of all the world leaders to world peace today at the Keshe Foundation broadcast sites, and it'll be all day signing the World Peace Treaty by either the nation's leaders or their, call it, delegated representatives if they fail to show up, which I think many of them will. So that'll be to their detriment, because we'll have to have a delegated representative to replace them if they don't have themselves or a specific representative show up. Well, that'll be interesting. So that'll start in about 3 hours at 10 a.m. Central European time. So we look forward to that on the Keshe Foundation sites. Okay, and so it's kind of a special day today. It is very much a special day today. This day may end up being known as World Peace Day, if all goes well, which it seems to be. So, noting in that sort of frame of mind, what do you got today, Lee? Let's have a look at your thing there. You get looks like a motor block from here at the small picture, but I'm sure it's something different. Let me just get this zeroed in. No, it's not a motor block, but boy, it looks like one that I saw in a truck that burned out recently, and the whole motor block was all melted because they have plastic all over them nowadays, right? So when they burn,
That's right.
when they burn, they just look like an ugly, dark mess, just about like that. But this is a mess with a message, I think. You got what the heck do you have here? This is one of your more exotic creations I've ever seen, Lee. And we've seen what, 100 different reactors, and this has got to be one of the most exotic. So, all right, tell us about it. I'll quit talking. I just gotta hear what you gotta say here. And you
See,
haven't
I'm looking
actually
at myself
plugged
in the
in.
mirror today, so I'm laughing and smiling.
And the strange part about it, he actually has it plugged in, folks. This is
I know I'm not supposed to,
there's
but I couldn't resist.
I don't even see a fire extinguisher handy. Tell us about it. What do you got here, Lee?
I showed you this project over a year ago when I started it, and it's been sitting on the back corner of my table here for a long time. So I decided to finish it so I could get it off the table and move my computer over to the other corner of the table so I could get some better lighting and show things off better.
Yeah, eventually you want 1,000 square meter warehouse for this kind of thing, you know, but yeah.
Maybe.
Well, at your rate of production, yeah. Anyway, yeah, so, yeah,
this is
geez. Holy cow.
This is an IQ 144. So this is Mike Nashev's design that he was making IQ 6s and IQ 24s, and I think he had an IQ 144 in his shop too.
Yeah.
Although he never showed us how to make them. It was more I forget the guy's name. The other guy who was making the Q devices was showing us how to make 144s and had plans for it, but I changed it from his capacitor design to Mike's Infinity battery capacitor. So there's 144 battery capacitors on this thing. Six layers thick here, and 4 per face for 6 faces. And actually, then there's in the middle here. There's a glass box about 8 inches by 8 inches by 8 inches that these are all glued to, and in the middle there's some more battery capacitors. It's similar to Mike Nash's core for his 6 IQ6, but I had to put, since I had so much space in there, I had some bigger ones, smaller ones, and smaller ones, so they nested one inside each other in the middle there. I figured that would work, and then there was still room for 3 or 4 Gans balls, so I got 4 Gans balls in the Starship formation right in the middle. What I'd like to do is to maybe spray the outside with H3 Gans, whatever that's called, tritium Gans, and then I can still lift the lid to get inside here and spray.
Oh my God! Look, it's got a lid.
I can
do that again.
Well, I can't.
That's wild.
I'm gonna bend my wires, all the wires on this one side, so I can bend it up a little bit, and I can spray some deuterium Gans in the middle, and maybe play with it that way a little bit. But
what does it do so far? Do you notice any effect at all?
Well, it works. I mean, I got
physicality or otherwise. So it works as far as lights light up with it and so on. So it works normally as
works like an ordinary maggrav for starters.
Mm-hmm.
Okay, beep wise, it's about a foot away that it stops beeping.
A little bit more than a normal maggrav, maybe.
Yeah, they're ordinary maggrav, like the factory maggravs, the Keshe maggravs, and the IQ6s. They have a field out about 6 inches. I got a couple of 24s, IQ 24s. They'll go out 10 inches, and this goes out 12 inches. So I was thinking it would go out maybe 2 feet or in the 2 to 3 foot range. So I'm a little disappointed that way. But
so in this case, size does matter.
Yep. So now I got a gradient of maggravs from little guys to medium guys to this big guy. So maybe that'll come in handy for a project or two.
Now that you mention that word, maybe you have since you have a gradient and you have the bigger and smaller, that gives you the opportunity to interact with 2 or more of the reactors, I guess. And this big guy he seems like a giver, like he's just gonna give to the little ones for sure.
Yeah, and so far all I've put on here is about 7 watts on the thing. I don't know, maybe the fields will get stronger if I put 2,000 watts on the thing or something.
Oh, true, yeah, it might make a huge difference.
Yeah, and I haven't tried that yet. I was going to do it just a while ago, but I got sidetracked.
Well, that'd be a great experiment. Let us know when you try that, or maybe you want to even try it during the workshop here if you get brave.
Yeah, well, I got a 1,500 watt heater just the other side of the room. We can go plug it in and find out what happens.
Yeah. And you do have a fire extinguisher nearby, right? Just in case our long fire hose would be fine.
What would I need that for?
Well, you just never know, and you could have a meltdown, a core meltdown of your hot glue. Nothing worse than a hot glue core meltdown.
Mm-hmm.
It's funny, but it's like the what was it, Icarus, who tried to fly to the sun, and he had wax holding his feathers onto his wings, and that might be the case here. Once this actually works, then you will have a core meltdown, and that would be the indicator that your reactor is truly working.
Yeah, maybe 14 inches, but
seems a little more than before. Like the thing would be
same amount, whether the thing's turned on or off is about the same.
Really?
So
okay.
Yeah.
So there's a possibility it might build up over time as well.
That's a possibility too.
Could be like,
but I don't need any more heat in the house at the moment, so
it'd be a good heater in the winter, perhaps. I wonder what the resistance of it is under load. That would be interesting too.
What do you mean?
The total resistance under load, if there is any, in terms of what losses are happening inside that unit. What would it put out if it was in a tank of water and you were measuring the calories that were being put off by it?
Yeah, I don't know. When I tested the resistance of the hot wire in to the hot wire out on the two the hot plugs and it was up in the mega ohm range.
Okay.
So
that means it's constructed properly.
I think that's a good sign.
Yeah.
So.
Wow. That's
what
a piece. It almost looks like it should be like put in a satellite and put into space or something.
What I was thinking, I still got that sort of health thing set up in my living room with 8 magravs in it and that pipe frame that I showed there about 8 months ago or something. I was thinking, so I got 4 magravs up on the top of the frame. I was thinking I'd stick this one up in the floor in the bedroom above, and that'll give me a starship formation with a 4 magrav base on it. And then I can stand below in the health thing and see what happens. But, so I might try that and see just for fun.
So when you hook up a meter to this, do you get any voltage out of it?
I never checked that.
You may have built a self-sustaining generator unintentionally.
I don't think so.
It sure looks like it could hold a lot of charge if it was charged up in some manner.
It's got 122.3 volts on the output at the moment.
Okay, so what if you unplug it? What happens?
Essentially, it goes to 0 or 50 millivolts.
Is that's on the AC scale?
That's on the AC scale, yeah.
Try it on the DC and see what you get.
On DC, I got. It's really close to 0. It was 15 millivolts there for a little bit. Now it's 5. Now it's 0. So
okay,
very little.
Yep.
Next to nothing. So anyway, another toy to play with.
There you go. You never know what it could be the core of at some point later.
Anyway, I figured it would be a good, nice, strong magrav to get my peace message out.
Yeah. Are you still feeling the fields these days? Have you felt any fields that are worth feeling lately?
Well, when I put my hands around this thing, I can feel some fields. And
only when it's plugged in, do you figure? Or like, do you feel anything beforehand?
Not really. Right now, I got no light on. But it's weak. I mean, I felt better, a stronger field on that hand scanner I made.
Right. Yeah.
But I was sort of asking it questions, trying to find out what its name was, and I figured out it's you sort of say, okay, if it's the answer's yes, then tingle my right hand. If the answer's left, tingle the left hand, and as far as I can figure, it's a female, and its name is Jocelyn.
Wow. So, okay. I see you've progressed a bit from just feeling the fields. Now you're naming them.
So that name came to me about 2 weeks ago when I was, and I don't, out of the blue kind of thing, one night laying up in bed, and I said, I wonder if that's the name of the new magrav I'm working on. And then today I was sort of, okay, what's the first letter? Going through the alphabet, and then when I hit the J, all of a sudden my right, I feel a little bit in my left hand, just really weak, and then I hit the J, all of a sudden I felt it really weak in the other hand. So then I sort of going through the alphabet for each letter in the name kind of thing, and it's spelt real funny, but it's sort of what I said, right what came to me as the name there a while back. So anyway, it's
And it might be just confirming what's already in your subconscious in a way that you've
Well,
already
could be.
determined it, and it confirms it, or it could be determining it in that moment. Hard to say.
Yeah,
Pretty worth looking into, though.
so anyway,
Okay.
Mr. Keshe says all these things have their own souls and all that kind of stuff, and and I know Mike Nashif and all those guys there all had names for their things, and or I don't know. I think the Magrav actually picks its own name, whatever. But so the trick is to figure it out. But anyway, I just got it turned on here late this afternoon, just to see how it went. So I haven't played with it too much.
How much does that thing weigh? It must be pretty heavy, eh? Like, you've got a lot of coils on there.
Yeah.
Not too bad?
Oh, it's 20 pounds maybe.
Okay, I thought it
maybe only 10 pounds. It's in that 10-20 pound range.
About 8 pounds of hot glue.
that's where all the weight is.
You have to buy all the hot glue from the local hardware store.
No, I had to order it in from the warehouse.
Oh, yeah, exactly. That happens with
they had 2 boxes on the shelf. Says, "No, order me in 10 boxes."
That happens with Keshe experimenters a lot. They run out of supplies in the local hardware store building their reactors.
Yeah. So whenever I got a project like this on the go, I got to go down there and order my hot glue ahead of time.
Okay, yeah. Very nicely. Anything else for us this week, or what
No,
others?
this is
other secret peace projects for global domination of peace?
No, this was going to be my global dominator right here.
Okay.
So
we all need a global dominator. Global peace dominator.
That's right. Get that peace message out.
It's global peace or else.
That's right.
Okay, thanks, Leo. Take it back to
Rick, could I ask?
Oh, sure. Yeah, let's ask Lee questions. Sorry, didn't mean to cut off that. Go ahead, Mark.
I just had a question because that's so interesting. How is it wired? Is it just one complete wiring, or I mean, can you just kind of?
Let me grab the wiring diagram here. I don't know any. Basically, you got two. You got the power coming in on either side here, and then you got 2 series of capacitors, about 48 of them each side in series, and then in between each one you got another capacitor in parallel.
So then it's just all one hot. It's all one hot way in, right? It's all hot in and hot out through your capacitors. Yeah.
So you got your hot in one side, and then the hot comes out the other side, and then at the other end, the far end, that's where it goes into the core of the box. Right. So you got 2 wires coming out of the core, right, tying in at the other end, and I don't know. I mean, it goes in, but it could come across that first capacitor and back out again, for all I know.
Well, it doesn't matter because we're just in parallel and series.
That's right.
It's all hot pushing in through it, right? No negative at all anywhere in there, right?
Any which?
No negative anywhere in there.
No, there's no common or no negative. The common just goes right through to the plug-in, the power bar.
Yeah. You know what it looks like? That picture looks a lot like an intestine. So it's like a flow. It seems that when you first put it up, it looked very much like from a bit of a distance. The picture looks like an intestine.
Yeah.
And in a way, the unit does too.
It's very easy to get confused wiring it. Each one of these has got an in and an out. You got to get that oriented right, and then every now and then you gotta, sometimes they go right beside each other and no problem. They're easy to wire, but then the parallel ones you got to wire, but sometimes you got to go from here all the way down to somewhere at the other side, because I go 4 here, 4 here, 4 here, and then I flip over here and I go 4, 4, 4. So it's, or, you know, so like 3 this way and then 3 that way, and then it starts over again for the next layer.
Where would be, where, if anywhere, where would be if you were to get a short, where would be a common place for like a short to happen there?
Well, on these infinity capacitors that Mike makes, is the inside wire on the plasma capacitor. It's actually folded back and forth 8 times. Okay, and then twisted with a drill.
Right. And
then dipped in in this case we're using ash water instead of caustic soda to nano-coat it. Although I pre-nano-coated all my wires with caustic, and then you know, did the twisting, then dumped it in the ash to get the final nano-coat. And so you got, and then the in and the out on each of the capacitors is on that wire twisted through the middle. So basically that would be it's almost a dead short kind of thing. If it was matter state. If it's plasma, you're supposed to get all these interactions between the wires going back and forth plus the twisting.
Okay. All right. That's cool.
So there is a possibility of getting a dead short on each one of these capacitors, really.
Well, probably in any case, because of the caustic breaking down. Is it aluminum foil that's wrapped around it?
Yeah, I'd say that part's the same as the Keshe capacitors. It's your core wire, then you got your paper, and then at the one end you got your aluminum foil with 2 coils on the aluminum and 3 coils on the paper. So that's.
But where does the ash come in?
Well, both for the Q devices and this IQ device, they weren't using caustic. They were using bare copper wire and dumping it in the ash water. And also, when you put for your paper, instead of painting it with Gans, you dipped it in the ash water and rolled it up. Then you dip your aluminum foil in the ash water and roll it up.
Well, wouldn't that be caustic, Rick? The ash water would be caustic.
Yeah, well that's how they make lye out of ashes.
That's right.
One of the ways.
That's how you make it. It's not necessarily caustic right off the bat, but if in theory, if you boil it down and so on, then it would definitely make caustic. And it depends on the ash, what kind of ash too. Different trees have different effects.
Different acidities.
Make it different kinds of lye. Yeah. They found the ancient people found that certain trees had the best kind of lye to make soap and so on.
Yeah, so pine cones are supposed to be good to burn, get ashes from pine cones, but I had a few of those, but mostly it was just scraps from the wood shop.
Well, thanks, Lee. I just was wondering about how it was wired and where, because I got one wired now too. You'll see, I got something to show, but I was worried, where's the short? Where does the short, to look for and stuff like that. But okay, I understand that now.
Okay.
Thank you.
Very good. Any other questions for Lee? Alrighty, we'll move off from that one. And thank you very much, Lee. That was really, really cool as always. Great seeing your stuff. Okay, Mark, you were kind of remarking there. You want to keep remarking along with some of your stuff?
If anybody else wants to go ahead of me, that's fine. You know me, I always have stuff.
you always defer, but you always have stuff to show at the same time. Yes, very nice. Is there anybody else who has something they'd like to show here? That they have to go later, they like to get it in right away, then now would be the time to get your question or presentation in, and otherwise we can defer to Mark. Going once, going twice. Take it away, Mark. What do you got for us today? On Global Peace Day, World Peace Day.
There you go.
Okay, just a second here while I get it lined and pinned and spotlighted and everything else that I have to do. Alrighty, now what do we, oh, we've got the, I just noticed the picture here, and you see the little whirligig in the middle, so it's this little baby's coming to life here, right? She's shaking, she's got a heartbeat.
We got a heartbeat. We got a heartbeat, my friend. Yeah, you know what, you know me, I overthink things, whatever. So, you know, and I tried so hard, and when I was completely done with it, I just sat in front of it and I just said, I want everybody to know that I did this in a peaceful intention, and whatever comes of it, comes of it. And I think I did something, or I ran into something here that we looked at it last week, but I didn't really realize what I was looking at last week. I was just kind of amazed that it actually kind of worked a little bit for me. So I've had a week now to just kind of look at it and kind of analyze it, but I didn't have the motor and the spinning egg last week. That's today's edition.
Let me get my live stream audio on. This changes a lot because I bet you have like a vibration or a pulse in the whole frame of the unit now. So the whole thing has a bit of a shake to it, eh? A little bit of a oscillation, you might say.
Absolutely.
So all the GANS balls and all the pipes that are, the pipes are filled, aren't they? Or
no.
Not, okay.
I wanted to keep it independent. I wanted to keep the spinning egg independent of everything else, because the small balls that are the colored balls are just freestanding.
Yeah, I know that, but I mean the vibration will affect them though, because they're now, everything in that structure is now oscillating to the vibration of that egg.
Oh yes, I can feel it in my feet.
Yeah,
but it's not connected any way to the frame or to the upper part.
Does it make you want to dance when you feel it in your feet? Like the Keshe dance music at the front of the workshops we have now?
Absolutely.
That's what you need to do. You need to tune it to the Keshe dance music, and then you got it.
Well, you know, I just actually, because I had a couple of different prototypes where I had the motor, and it was I'll show you how it builds up power and everything, and it actually does what it wants to do. But I had made plastic tubings for it, and I made a 4-legged prong leg for it. And it didn't break it; it melted the pipes. It had so much torque on it that it just tore them to pieces. So then I just thought, what am I going to do? So I rummaged around in some stuff, and I found a piece that I bought almost 2 years ago at a rummage, at a resale shop. Something I thought, this looks pretty cool. I'm going to buy it. It was like $5. It was a little stand or what. I thought, man, you never know. 2 years later, I got to use it. I just can't even believe it said to me way back then, don't worry, sir. I'm going to come and hand you someday. Don't you worry. And sure enough, it did. So I made the stand, and then I weighted it with a couple of big weights there, because what it was doing, it wanted to kind of walk. It wanted to turn.
Well, yeah. What is the motor from again?
I don't know. It was another rummage sale.
It looks like a pretty big motor. Is it 12-volt kind of deal, or maybe it's from a? Is that one of the weed whacker motors, or what kind of thing would it be?
I don't really, Rick. I couldn't tell you. I bought it at, it's it has 2 leads on it. It has.
And what do you got running on it now for voltage? It's on your power supply.
Yeah.
Okay, yeah. If we could see that a little bit, I can't quite make it out, but that's okay.
Yeah.
Just tell it. What is it running at now, roughly, or is it very? What's
well,
it
right
varying
now,
from?
it's running the output on the power supply is 8 volts, and it's 1.27 amps.
Okay, so it's about 10 watts basically then.
About 10 watts, and then I have my electrical meter hooked up to it in a couple of different other spots to get a reading off of it to see how much I'm either losing in the system, and I'm getting it's reading 7 not quite 8 volts. It's like 7.16, something like that. It's losing about 80 something. You know what I'm saying? The difference is 720, and it should be up to 800, where it's saying 720.
That's 0.8 volts. Yeah, that's a fair amount. That's probably due to the lines are too thin, or there's resistance somewhere in the lines or something. But yeah, okay, so it's probably like a 12-volt motor, and it's just running on 8 volts now, so it's running at what, probably a few hundred RPM or something.
Yeah, I would say at least 500 RPM, maybe 300 to 500.
Yeah.
But the thing of it is what you're looking at, but what we don't realize is I have the power for the power supply and the negative for the power supply attached to it, and I've taken the motors running off of positive and negative off of the unit itself. So my question to you and to whoever's looking at this, I'm putting material AC power into this unit, and what's coming out of it and supplying the motor is that plasma energy, because it's I'm running.
Wait a minute. Are you running? You're saying you got like 8 volts. Is that AC that's going in? 8 volts AC.
AC.
Oh, okay.
Oh yeah.
That's different. All right. And the motor is probably a DC motor, though, I imagine.
It's a big motor. I don't know. How would you tell? How could you tell?
Usually there's some stuff printed on the motor somewhere, a tag or some stamping, some stamped numbers or something you can ID it with.
The only thing it has is a Chrysler stamp on the center and the back.
A Chrysler stamp. Okay, yes. Well, it would probably be like a window motor, a window wind-up motor.
Oh, it's pretty big. I don't know.
It's not a starter motor, right? It's not that big, right?
No, I'm thinking it, but it had a nut on. It's more of the same size as like a vacuum motor.
What kind of shaft was it? Just a straight shaft, or?
Yep, just a straight shaft.
About what, a quarter inch or something, maybe a little less, 3/16. Okay, well,
the nut on it, the drive nut is a quarter inch. So the shaft might be just a hair littler than that.
I see.
So, but I'll give you this information. What I, like the little sleeves that you put lamps together with, those little sleeves.
Yeah, I had one in my hands 2 hours ago. Believe it or not.
Believe it or not, it slid right over the shaft.
Gotcha. Yeah.
So then what I did was I drilled a hole through that lamp, that threaded lamp piece, and I put a nut and a bolt through it. And then through that, I used the lamp pieces. And what I did was I took a 3/4 inch cup or an end of one of the PVCs, and all the pieces for the lamp that you put a lamp together that screws together. If you drill that hole out, it fits in there perfectly to screw that all perfect so that it's nice and tight. I mean, there was no play in it at all. Then I just epoxied the egg to the top of it.
Right on, cool.
It's not, you know, there was no way. I tried as hard as I could to try to get it as perfect, but there's no way there's no way I could have got it perfect. But then I started thinking, why do I need it perfect? I want that wobble because
that's the thing about it is, I think the wobble factor is very important actually, and maybe that's something that we have overlooked in the past, because anytime you have wobble, then you've got a unbalanced situation that's always trying to return itself back to balance. So if you have, if you want to introduce an unbalanced situation in order to create a pulse or create some sort of vibration, an oscillation, a resonance, gives you an opportunity for literally shaking things up.
I don't know if you're going to be able to pick up that. It's just going to flash like that. If I got really close to the output. But sometimes that output,
cool.
Yeah, you know how hard it is to get that readout.
Yeah, we can't get both probably. So, what's on the bottom of the motor there? That's kind of like a clamp or something around the bottom. What's
way down here?
Yeah.
That's a 5-inch C clamp.
Oh.
Band clamp.
Okay, and the band clamps to what?
Can you see this little green thing here?
Yeah.
That was a base thing that I found, and it had a round base on it.
Okay.
A 5-inch base.
Gotcha. Mm-hmm.
So the engine sat right on top of it.
You can't mount it. You can't mount it right onto your frame.
Onto here?
Yeah. Because then you don't have to put your balance weights on there, and that would allow the thing to move around as it prefers on the floor, and that would be really cool.
I tried that, and it just broke everything apart.
Yeah, that's the side effect if you don't reinforce it in a certain way, I guess. Or put a rubber mounting in so it doesn't destroy things, yeah.
I mean, I got rubber mounts underneath the weights just to keep it so that it, to keep the balance of the engine because of the wobble.
So,
can you hear it right now?
No, we just hear you. It's actually pretty good.
Let's give it a little juice.
Yeah, give her some juice. What the juice?
But the thing is,
and now we're hearing a little bit. Just barely hear it there. The noise canceling microphones do weird things with these motor noises.
Can you hear it a little bit?
Yeah, very little bit. The noise canceling tends to cancel it out.
Well, the funny thing is, it changes volume as the wobble starts to find its own position.
Mm-hmm.
Yeah, I got glass in front of it too.
Oh, I see. And what's inside the ball now?
What's inside the egg in here?
Yeah.
The egg has the crushed quartz sand crystals, completely filled with the crystals, and then I put the 3 different types of GaNs in there, or the 3 different types of CH3. I have
it's liquid plus the sand then to fill up the whole thing?
Yes.
Okay, got it. And what were the combinations you were going to say?
Well, the 3 combinations of the 3 different CH3s were the Himalayan CH3, the biosalt CH3 and the potassium magnesium CH3. And then on the outside, I don't know, I could slow it down, but I have a ring like I showed you last week. I have that outside ring in there. Yeah. And that ring has just a small amount of each one of those in there. And then just a small amount of CO2 and then another drop of zinc oxide for the outside ring. So that's the way the whole thing was produced, up and down. But like I was saying, and I can take a hot, you know, like the way it's wired is everything on the outside, everything up here is a hot lead. That's a hot lead. That lead goes down. All my top ring is all hot. It drops into here, drops down out of this top ring down to the bottom ring, fills that bottom ring, comes back out, and then travels along the top of the capacitors all the way back up to where this is the hot lead right here. And then it'll send it back down. And it's just a complete loop. And then the second thing was, I used the middle one as the negative, but these two capacitors are in reverse polarity, meaning that I can take a plus read off the top here and a minus read off the outside of the capacitor here. And that's the same way through all the capacitors except for these two, this one and this one. Every time I took a reading, it was the opposite. The inside core wanted to be negative, and the outside core wanted to be positive. What I didn't understand was I needed two of those to do that, because that changes, that flips the polarity from the top to the, you know, it takes the, without having a place to where it shorts out. There's no place for it to short out because it changed right here from the inside to the outside. It shouldn't have changed here, but it does. And it just gave me two ends and able to be able to connect to at the very end. So now I know exactly how it's wired, and I could do it again if I had to. And it's not that hard of a deal to understand that. And I think once you make enough of these capacitors, some will be positive and some will be negative. I only had these were made a while ago, and I haven't made anything else. I have the same idea and design, but when we went on hiatus, I just stopped everything. So I just kind of didn't do anything and just let it. But now we're in a point where peace is at hand, and I hope that I can project my piece on one of the. I'm so happy that this is just this is my gift to Mr. Keshe on his birthday, and I hope and say and just allow this. The only reason why I have this is because he allowed to share his goodness with us, or goodness with me, and I'm so thankful. There's not too many people that share good things with people in this world nowadays, and he was a person that said, hey, you know, if you're willing to do some things and try some things and listen to some things, I'm willing to give you a chance to know some things that I know. And if you just keep your mouth shut and keep your head down and be very aware of everything that you do, good things will happen. Very good things will happen. I just hope that he has the very best birthday that he could ever have in his entire life. That is my wish, my hope for Mr. Keshe today.
Thank you, Mark. That was wonderful, and yes, I think we all wish Mr. Keshe a very happy birthday today, and that was my wish too, that he has the best birthday of his lifetime. In fact, of all, best lifetime in the best birthday in the universe. Why not?
Why not? Absolutely. So this is, you know, there's a lot more things I for observation. Like I was saying, you know, I could start to try to push more power through it, but the unit won't let more power go through it until it's ready for it, if that makes sense. Like right now, I could push the voltage up to 30 volts, and it would only accept 9 volts right now. But if I left it running for another half hour, 45 minutes, it might allow 12 volts to go through it, and then you know, and then 13 volts, and all of a sudden and then it kind of finds its balance again, and it stays right there, and then I feel like going up a little bit farther.
Yeah.
Because if I left it as, I can't show, I'm at 10 now and it's at 9, but you know, I got it cranked up open. That's max. Can you hear it?
We heard it accelerate, but then we can barely hear it now that it's running. It's funny. The microphone cuts it out.
Because it's almost perfectly balanced right now. There's hardly any vibration at all to it. But you can see the wobble in it.
Mm-hmm. Yeah.
And I would estimate that it's probably going at least, I want to say at least 2,000 RPMs.
Yeah, I think more than that. More like 3 or 4 probably.
And I'm not too worried about sitting in front of it right now. Like I said, I got the plexiglass, but I mean, everything that's put together right now, it's humming right along.
Yeah. So far, so good, Captain.
That feels good. I mean, can you see the green? Oh, you can't see the green light, but there's a little light on the top.
Yeah. Oh, that's an LED that's on. Okay.
Yeah.
That's green for go. We have ignition.
So that's one of my little projects. Just like I said, this is a little dedication to our friend that gave us so very much. I'm so happy today. It's a peace day. I feel peace in my heart. I'm so happy. And it's like I said, I'm just happy that it's running, and you know where I'm going from here. I got the big one just ready for it. I'm ready for that big one, ready to go. So I don't know. Maybe I'll make a little tritium out of it. Maybe I'll get the separation. Maybe. Only observation at this point now.
Yep. Nice work, Mark. Hard to tolerate the full speed all day, eh? Is that maxed out?
You want me to go a little closer?
Is that maxed out now? Can't hear me.
I can't hear you.
Yeah. Is that maxed out?
I don't know. Let me find out.
Oh no.
There's still a little more room, Captain. She's holding good though. I'm staying back a little farther this time.
Yeah, it's really winding out. You gotta.
That's 4 amps at 28 volts.
Yeah, that's a lot more. That's about 120 watts, so it's 10 times more power than you had before. You heard a little grrr there, a little growl. A little growl came out of it when it decelerated. That's all we heard.
That's what happens when you come out of hyperspace.
Yeah, that's right. It did that when it accelerated and when it decelerated, but otherwise the noise canceling microphone seems to block the sound. It's interesting. We only hear the transitions rather than the constant sound.
Is there any way I could take that out of there and just have an open mic?
I think the Zoom automatically adjusts the sound and cancels it, or perhaps it's in your microphone itself. I'm not sure.
Oh.
Most microphones, we hear it chattering along a little bit there now.
Yeah, it's kind of at low speeds. It's got a little chippy sound to it.
Yeah.
It's ready to take off.
Different personalities. It definitely, when a little sphere like that revs up, it gets your attention. At high speeds, you start to have a lot more respect for it, especially if it gets up around 10, 20, up to 30,000 RPM. Then you start to go, whoa! There's a lot of energy behind this thing.
I mean, that's an 1/8-inch plexiglass, and it's plastic, but I don't know. I'm sure it would.
Acrylic or polycarbonate? That's the thing.
It's acrylic.
Acrylic will break, yeah, but it'll buffer pretty good, but it will shatter. Whereas polycarbonate of that strength, it'd pretty much take a 22 bullet would bounce off.
Well, that's what I got.
Nice. Thank you, Mark. Lovely.
Sure.
All right. Anybody else with something they'd like to show and tell for today? Could show sort of a cute little project that I've been playing with here. I've been looking at these spinner toys that you see in the supermarkets and so on these days. You hold it in your fingers and give it a spin, and it spins for quite a long period of time. It's got pretty good bearing in the middle. And some of them, I've got another one over here.
You've still got Mark highlighted.
Oh, I'm sorry. Thank you. There I go. I would explain the stun silence. I'll show better here. This is called a spinner toy that you see in the supermarkets and so on. You give it a spin, and it spins pretty good for a long period of time. Okay, I've got another one here, black one. Same thing, spin it. The difference is this one doesn't have any bearings in the middle. It's all just solid pieces. This one, however, it's got 3 nice little bearings on each end here. So when you spin it, they have a chance to move themselves if they wish to, and so on. It makes it a little different in the way it performs. So what I propose to do, which I've been just toying with the idea until I have a bit of time. I don't have much time today. I'll take this, and I've got these little containers, these little bulbs, and the idea is they have a cap on the bottom. In fact, some of them that I have a screw end on it. I was trying to find. Oh, where did it go? Let me just see if I can find that. Just for a moment here. Well, can't locate it right now, but suffice to say, there's some of these have little screw ends on the bottom, and some of them have a rubber plug. Some of them even are just sealed totally. But these ones are actually unsealable, So you can turn it upside down, use a hypodermic needle, and inject them with GANS water or GANS. Okay, so and the idea is you can hang them as a sort of an amulet thing on a string around your neck, or you could put it on a bracelet, or you could mount it in your dash of your car as an emergency GANS supply or something, whatever. But the idea I thought was I'll take 3 of these and mount them inside this thing, sort of like that. And I've got 2 and I don't have 3 right now, but there's 2. Okay. So the idea then is once they're filled up with GANs, it's pretty simple to spin them. So we have 3 little reactors in bearings so they can rotate as they wish, rotating in the outside of this little rotating reactor thing. And you would think if all goes really well and you have loaded your reactors with the correct combination, perhaps this little spinner would just keep spinning. And wouldn't that be nice? You have the world's first little demonstration of a plasma-powered reactor that starts by push starting. You give it a little push and away it goes. And the great thing is you can reverse it at any time. If you want to undo the field effects that you just created and planes are crashing from the sky or something, you might want to undo it by reversing the rotation. Anyway, what do you think? Is it a winner? Is it going to make it into your supermarket? Who knows?
I'll give you a thumbs up on it.
Good idea.
Thumbs up, eh? Oops. There it goes. Well, another idea bites the dust. Well, you get the drift. Like you can actually spin these things so that you can, if you're good at it, which I'm not, you can spin it and have it balance on your thumb. Or in this case, you can spin it, have it balance on your thumb, add a full ball of GANs to it, and you can imagine with the 3 reactors rotating. See, I lost attention briefly. It requires your full attention. But you can imagine this rotating. I mean, I could put it on the table with the GANS ball sitting on it. Could be glued on, but it just happens to have a little divot in here that almost fits the ping pong ball. So it will actually rotate. In fact, I can hold the ball. There we go. Now with the 3 little reactors, I'll put the 2 in that I have. See if they fit. See if this will all work. Got another one, but it doesn't have the doodad on it. But I think it'll suffice. So we got 3 little reactors. Okay, now we got 2 little reactors. That one didn't like to be in there. So you get the idea anyways. We would have 3 reactors rotating around the central core reactor. And you give that, oh, I guess I lost 2 of them. If you give that a good spin, see, I would set this up so that this actually has a rubber seal around it, and it pushes in there nicely and locks into place. So 3 of them, okay, none of them now, but you get the idea. 3 of them rotating around the ball on their own bearings, and this thing will run for several minutes when you give it a good spin. Mind you, there'd be more air resistance with 3 globes on there, but also more weight, so it might go even longer. So it could be sort of a tension device. You have to focus your attention on this to hold it all together while it's all rotating, and you know, it's you could focus your attention on world peace while you were allowing your reactor to go. You might want to, you know, you could actually walk down the street with this in your fingers and be using it. Maybe you could even mount it on your chest as an amulet that you spin every once in a while. Or how about this one? Mounted on a hat. As a little propeller thing, and you've got a reactor combination on your hat.
Which store did you find those things in?
Give a spin every once in a while. Pardon me?
Which store did you find those things in?
I found this in the world famous Canadian Tire in found in every Canadian city. So they're, you know, $9.99. It's pretty cheap actually for 4 bearings. You can't even buy 4 bearings for $10 these days, so it's a pretty good deal. You could always remove the bearings and use them in something. They're pretty much skateboard size, but not quite. So it's actually a pretty good basis for a small reactor. You could put tubes in here and have the reactors accessible through screw holes and whatnot, and they could be in different heights, and you've got that central bearing and the 3 bearings all set up ready to go, and nice aluminum casting. So that's a little a piece project here, if I can get a few minutes spare time to actually work on it to complete it. Got some little glass balls sitting on the floor here I have to pick up before I step on them. That wouldn't be too good. They are pretty tough little spheres, these things. I've rotated them up to 10,000-12,000 RPM, and there's no problem as far as longevity goes. I've actually dropped them on the floor and had them not break. I've broken a couple too, which can happen, but they're what you do is they come like this, the hole in that end, and then you get a fitting kind of like this with a hole in the end. Demonstrate. And so you can fit that over the other piece and glue it on. Actually, you end up with something like that. And then there's a little screw piece that goes in the end. You screw it in, and that seals it. Or or you can also have just a little rubber plug that goes in and seal it that way. The screw piece has a hole, so you can actually put a threaded thing in it and hang it, or put a loop on it and make it into an earring or something like that. And I don't have a demonstration one here, but the ones with the blue CuO copper oxide GANs are just beautiful inside of here. Maybe I'll go and squirt some in and try it here if I get a few spare minutes. So 3 of them, or set up with, you know, CH3, CO2 GANs, and copper oxide, or any combination you wish, basically, can be experimented with. No motors needed, no batteries included. Okay, there's your top secret hint for the day, for the week actually.
I like it.
See, you know, for about $20 worth of materials, you've got a working 3 or actually 4 core with that, a working 4 core reactor for $20. Not bad. these things here are available. We talked about them before, but they're available on eBay. I think, what are they called? It's like Flask or something under. What do they call these things? It's a specific name for them, which I don't recall offhand. But you can look at them under miniature globes, fillable globes. What the heck is the word for it? Something like that. They are. You can search. You'll find them.
You could expand on that idea, Rick, for that the Starship spinning balls. You could somehow, like I was going to use a bicycle hub in the center for because it's got ball bearings on it, and then you could have a disc of plywood on that, and then you could embed a ball bearing, 18 ball bearings around the disc, and then glue a ball on each one so the ball can spin as well as the whole circle could spin for your Starship with the spinning balls on it.
I think I lost you just on that last part of connecting. You say ball bearings, like 18 ball bearings, that would be on the plate?
Yeah, get 18 ball bearings and just drill them in and mount them on the plate, and then put your ping pong balls on the ball bearings so the balls could spin, and then the whole plate could spin as well. So you've got instead of building the cage or the track for the balls to go around on.
Yeah, I'm not sure if I'm still visualizing the way you see it there. Maybe we could do a little, let me do a screen share thing here so we can figure this out, because it's good to talk about a couple of different designs. Let me see here. There we go. This out of the way, and this up. You see the whiteboard there?
I do.
Okay, so can you draw on it what you mean, Lee, to start with there, or maybe I can? If you can, go ahead.
Imagine that's a circle.
Okay.
And in the center here, I've got a bicycle wheel hub, which I've taken the spokes off of, so all I got is the hub in the center with the ball bearings.
Mm-hmm.
So you can screw this, say this is a 1/2-inch plywood or 1/4-inch plywood, and then you could screw it to the holes in the hub where the spokes used to be. So now you got a spinning disc basically. Then if you drill a hole for a series of ball bearings around the outside, then now you got, and then you just glue a ball to the the inner part of the ball bearing so that your ping pong ball could spin.
I got you. Okay.
Bearing.
Mm-hmm.
But it also the whole plate would spin. So you'd have
Right.
18 of these balls around the outside. Mm-hmm. Each ball could spin on its own, and then you could spin the whole plate. Because what I understand that they were showing at the Arizona factory, they had actually a track for these balls to run in, and then they had a motor on the track spinning the track around, and the balls were sort of going around.
Yeah, the idea being
that's the same as spinning the plate, but this also lets the balls spin themselves without the interference of friction and because there's a lot of in that track, there's a lot of friction where the balls can't really spin on their own, whereas this idea here,
true, yeah,
the ball can spin itself.
Ultimately, with the ultimate track, then there wouldn't be hardly any friction with the idea that would contain them without you know, the resistance or friction that could be involved there. And that's a tricky thing with the track system. But it's also, the idea with the track is nice because the balls can position themselves with their neighbors easier. You know, they can do a positive positioning.
Depends how much space you have in the track. You know, spare space. If you had, you know, a couple inches of spare space, they can sort of group together or ungroup. But
yeah, right. I don't know if that's important, or is it more important to maintain the positioning that way, like you're talking about, and allow the rotation instead, which is the advantage of the system you're talking about, and my little spinner thing as well, which you know, you're locked in with a lot of parameters with this. You don't have the variation between the balls that way. You'd have to, you know, it's all preset basically.
Well, even if they're going around in the track, I mean, the balls are all preset basically. They can't change positions or whatever. So it's.
Well, they might rotate and position themselves differently if they were actually interacting with each other. Yeah.
This is one of the projects I'm going to be doing here shortly, and I got the bicycle hub for the center, and I was going to actually mount a disc on that, or some spokes, you know, a sheet of plywood basically, and then build a track on the outside edge for 18 ball. I was going to make it fairly small as I could, with maybe a ½ inch extra space, plus the 18 balls in the track, and and then have some kind of motor. But I like this. I like this idea here with the bearings on it. Then the balls can individually spin up however they want.
Yeah, and it'd be a lot quieter too. The track thing is inevitably going to be noisy, it seems.
Yeah, and there's no friction for the balls to spin on here, basically.
Yeah.
The friction of the ball bearing, which is next to nothing.
Yeah, it would be interesting to see what happens, because when a disc like that is rotated with a ball and a bearing on its edge, then the ball normally rotates a revolution for every revolution of the disc, and that gets interesting at certain resonant frequencies and so on and so forth.
Yeah, I think I'm going to build it this way instead of the track, just to see, because I think this is a great idea.
Yeah, right on. Well, I've ordered one of the 4 reactors Starship configurations from Keshe Foundation USA. So that's kind of going to be the basis for something like this to put together with that and make the magic combination.
Are you getting it shipped up?
Yeah, I'm going to. We're making a special arrangement to see if we can do shipping and try to make it worthwhile for them, and so it all works out and so on. So I was trying to work out some of the glitches or possible problems that might happen if you do order and so on.
Yeah, I was seriously thinking about ordering a set of those things, because I can't seem to get anything balanced and working leak-free and everything else.
Yeah, there's some pretty extensive engineering that has to go into that kind of thing, and it's more than meets the eye. And I figure if I can get it, and if I notice improvements or find a source or a way to make it better, then so much the better. We can exchange ideas and keep upgrading these to make them essentially bulletproof, so to speak. Hopefully there will be no more bullets after today, but we might want to make them bulletproof anyway. Okay, what else about that, Lee? Any other ideas that you want to present?
No, I think that's good. You've given me a great idea here today. I like it.
Right on. That's what we're here for, to give each other ideas and keep moving things forward.
All because of a kid's toy.
Oh, kids' toys have been often the source of not amusement here, but inspiration. Actually, I could look over my. Oh, I actually got rid of some things that were. Oh no, I didn't either. Like this little simple doodad here. Let me spotlight my video here. I'll have to stop the share, I guess. There we go, and make it bigger. Yeah, this little device here it's a little spinner thing that you know, the kids play with basically, and you can do, you know, cool shapes with it. And I don't know, when I first picked it up, I just went, wow, is that ever cool? You can do things. This is like, to me, this is like the these are like the maggrav field, or the vortex field, you could say, around you know, an object, or the fields. And so you can play with this as if it was fields, especially when it's rotated. You can see how the fields take on a special effect that looks more solid when it's rotated. When it's not rotated, you see it's just rays. So rotating rays can have the effect of solidity, you might say. And the interesting thing is you can do things like wrap this up as a package. It doesn't have to be this shape. You can bend it a little bit and it wraps itself up into a ball. Essentially, it's a, if I do it right, it's a ball within a ball, right? So it's all, it wraps itself up into its own perfect shape, sphere. If I unwrap it, it's actually another sphere within that sphere, and that becomes like two spheres. And that's interesting in its own, as its own shape as the figure 8 interaction of fields. If you give it a little more spin, there's another configuration.
It's your 3D infinity loops.
Yes, exactly. And you can see how the energy can spin and get all wound up, and then, you know, when it's released, it's in a totally different energy pack, and it's you know, released form. And it's almost like you could go ahead.
There's your free plasma ball.
Yeah, essentially, yeah. And it's like, if this is the neutron, for example, and Keshe talks about the proton and the neutron, well, it's almost like this comes out as the electron, and as the electron's born from the neutron, and we have a electron and proton now that are both tied together through, so if I review that again, suppose you could say this was the neutron, but it ends up with it's a little hard to get this thing to cooperate sometimes. Or maybe that's the neutron, and inside the neutron has the proton comes out, and but it has a relationship with the, or rather the electron comes out, and what's left is a proton. The proton and electron have a relationship between each other. and maybe eventually all becomes back to one entity, eventually forms its own center again inside. Saucer shape. This one, there's a transition one there somewhere. See the core within a core there sometimes, right? Well, I think I messed it up a bit actually. Come on. Something went, some of the rays got astray. Oh, I see, it's just got wrapped up around itself there. So anyway, you get the idea there of transforming fields. And the idea being that kids' toys can be pretty educational sometimes if you play with them and inevitably. Ah, there we go, back to normal again. I think it was easier there now. There's the sphere within the sphere, you can see it there now. Before it springs out. Alright, well anyways, kids' toys. Joys of kids' toys.
Ask me later. I'm in a trance right now.
I was going to say, ask him a question. Ask her a question and she'll give you a yes or no answer, but not for today. Alright, let's carry on here. Getting a little far astray perhaps, but we're always on point one way or another. So I'm going to be ending fairly soon today because I've got a lot of things in the background to do to get ready for the World Peace Day and the signing of all the world leaders to the World Peace Document, which will take all day. Oh, Mark, beautiful shot. Let me get you in here. All right.
So, you know, I know you really have to go. You've got a lot of stuff ahead of you, but
we're good for a few minutes here. It's okay. Go ahead.
Just again, one simple question. Anybody that's an electrical engineer or anything like that, you know, that knows electricity and how electricity works. I just don't understand how I have a positive and a negative on this system. And number two, since I do, and I'm taking that brown wire is feeding the motor that is turning the egg. Is that plasma energy that's turning the motor for the egg? Those would be my two questions I'd like to ask you or the group or anybody that has great wisdom.
Well, you got two, you're mixing eggs and apples there, because you're asking a electrical person whether it would be plasma energy powering the motor. They would probably say that it's like a transform the AC into DC for your motor, or through the coil system, or something like that. But on the other hand, you could say that it is been converted into plasmatic energy through your system there, and it could very well be plasmatic energy, different than a normal DC current powering this thing. So it could be, if you were to look at it with an oscilloscope, it would probably be some sort of cross between an alternating and a DC current, maybe a pulse DC or something like that could come out of it. Or maybe the motor is actually functioning on an AC circuit as well. You'd have to really, you'd have to measure the AC and DC going into the motor. What do you get on the leads? What do you get when you put your multimeter on the leads, on those two brown leads, for example, when it's running, and you put it on AC?
Right on the two positions where they're at?
Yeah, where the two brown leads from the motor connect. Just put your multimeter on them, plus and minus, doesn't matter which way, and see what it says on the AC scale, and then see what it says on the DC scale.
So bad. Hold on 1 second. Okay, just so that we can see exactly, so that I know exactly. So, can you see the two browns?
Yep. Yep.
Okay, so that this is what I designate as red for me for positive, and I put my black as my negative.
Yep.
Okay. So on my handheld meter, the one V has one squiggly line on top, or two squiggly lines on top, and one. Oh, wait a minute. The one V has 3 dashes and a 1 long dash on top. What does that mean?
That'll be your DC, I think, and the squiggly one should be your AC.
Okay, so squiggly, one single squiggly over the V is.
That should be your AC. Mm-hmm.
Okay, and the other one is DC.
Believe so.
Okay, well, that's the way we'll proceed it, because that's the way I'm reading it.
Yep.
The V there's a V with 3 dashes and a long bar on the top. And right now, it's given me.
Okay, so that's the DC you're talking about?
Yep.
Okay, so 5 volts DC, 5.2, 5 1/4, somewhere around there. Okay.
Yep.
Try the AC now. So is that 8.9 volts? Huh. So you got 9 volts AC and 5 1/4 volts DC. So you've got an AC DC converter there, maybe. you get to have whatever you want, AC or DC out of it. Take your choice. The motor takes it. The motor takes its choice, actually. So the question would be, can you run an AC motor off that? Can you run a DC motor off of it, and both of them be happy?
So that answers our question. Both of them would be happy, right?
I think so.
Because if I turn it up right now,
you'd have to have a 10-volt AC motor, which there's not too many motors that are designed to be AC. All right, yeah. Wow. Yeah, that's overdriving that motor quite a bit, probably. That's pushing it hard for sure, Mark. That's like the drag racing of Magravs there.
That's
Detroit.
Motor City.
That's Motor City. That's what we do there. I used to race my motorcycle in Saginaw Speedway.
Oh, really?
Well, I raced there once. I didn't used to. I raced there once, and in what's the other one? I can't remember offhand, but yep, got a trophy to show for it.
I don't know. I live close to Mount Clemens, and Mount Clemens had the Mount Clemens Speedway, and it was a quarter-mile track and a half-mile track on the outside, and I couldn't afford the half-mile, but I had a little quarter-miler, and that was back in '85, and we just like to, have a little fun out there every Thursday and Saturday night.
Those internal combustion engines can be a lot of fun, especially in the old days. But the new days, we've got several cities have recently declared that they're going to eliminate internal combustion engines and diesel engines by 2040, including London and I think Paris. Sounds like a Model T.
Well, let's crank her up, Sonny, because she's a fine jalopy of a day. Because I know you got to go. We're just going to have a little bit more fun. This would be a good way to kick us out of here.
Boy, it's got some funny wobble to it. You can see in the video. It's the video captures the wobble in slow motion, kind of. It's interesting.
And I think it just finds itself a balance point.
It's a lot of I don't know if she's gonna hold together, Mark. There's a lot of unbalance there. $50 volts.
That's all she's got, Captain. What a loving it here in Detroit.
It's funny, we just hear this sort of whooshing noise. Sort of a... Except when it's accelerating or decelerating, that's when we get the noise, like now. Sound like a race car there. Wild, thank you, Mark. Good run.
Dead stop, and we still got power.
Dead stop? Is it?
Yep.
Is your what's your power supply say right now? Your main power supply. Leave that on. What's your main power? What's your power supply say?
Voltage is 4.00 amps is 0.853.
Right. So if you turn off your power supply, will you get a little bit of remainder happening, or will it just cancel right out? Okay, it goes right down to 0, it looks like.
None. Boom. Good night.
Yep. Well, interesting. That was fun. Thank you.
You betcha.
Reminds me of the old days. The old days of drag racing, and when cars had tires on them and motors in them and burned gasoline. Remember those days? Yeah, those were the good old days before all these electric things and flying cars and instant transportation. It used to be all the fun. It was going from one place to the other and taking a long time. That was the big thing about it. It wasn't about just getting there instantly. It was about how much rubber you could burn on the way. How much rubber and oil you could burn on the way was important.
How much noise you could make.
And noise, that was very, very important. That's right.
Got to have the rumbling V8. You got to, got to have that big rumble with the straight out pipes and the take off the mufflers and.
Yep. Yeah,
get it happening.
That's all. Used to be
we
very
always
important.
said we were sorry. We always said, "Excuse me, we're sorry," but man, was it loud!
And now it's funny, but now you find most of the tracks of the old days have gone bankrupt because the neighboring area has now been grown up and has been developed, and the people complain about the noise. So they have to shut down the tracks and so on. But now some of those tracks are rejuvenating because now they have the electric car races, both in drag racing and in circle track racing, and even in the Indy 500 type races now. And soon you'll see electric in NASCAR, and that'll be a big change.
You'll see that. It's a funny thing when you're sitting in traffic now and you hear the motor go, "Ching!" And I thought, why is these people starting their engine every time we're at a stoplight?
Because it's the hybrids starting up. Yep. Yep. Well, they banned internal combustion engines and diesels in several cities recently. I think in London and Paris and a couple of other places. And that's the way of the future is you're going to find all the countries of the world are going to ban diesel as quickly as they can. They're trying to drop that like a hot potato after they found out how destructive it really is and how much all the diesel manufacturers, the diesel car manufacturers have been cheating on their emissions exams, and they've been caught at it. And there's just another round last week of another few 100,000 vehicles have to be recalled and changed from years ago. This is vehicles that were, manufactured 10 years ago that the manufacturers have. Mercedes just had to recall 1 million vehicles recently. Can you imagine how much that's going to cost? But to them, it's just the cost of doing business. It's not that big a deal, but their name now is tarnished, and they recognize that, and they're not pursuing diesels anywhere near like they used to. In fact, Volvo just made an announcement they're going to all electric starting in a couple of years, and they're phasing out of all their internal combustion engines. This will be the way of all the manufacturers. Within 5 years, you won't have manufacturers making internal combustion anymore. It'll be an afterthought.
Let's stop and talking about all those bad people, because this is the day of peace, and we are hatching.
That's right, and this is the way it used to be, so now we don't have to be concerned with that so much, and I'm so grateful that the world is transforming the way it is. It's just such a blessing.
Mr. Keshe has laid a new egg for us, the golden egg.
Yeah. They said it was the golden age, but no, it's the golden egg. That's what it's really about. And we see it here in Mark's reactor, the golden egg in the middle there, eh? Maybe it will make gold. It'll make whatever you want it to make. Wasn't that the promise of the golden goose?
Absolutely. So, Rick, you know you have it's a very big day for you.
Yeah, I should go and get prepared here. So, yeah, thanks everybody for attending as usual. And let me just get my spotlight on here and say goodbye, because do have to go, and we could easily go on for a couple of hours probably on various things, but enough for today. I think we'll go with our spinner for peace and try that as a concept. Maybe I'll have it ready for the workshop coming up tomorrow. And pay attention today for the World Peace Day and the signing of the World Peace Treaty of the Keshe Foundation by the world leaders. And we might be surprised who those world leaders who are signing really are. And I think all of the world nations will be signed one way or another. That's the clue.
Rick, I would like to say I am Mark Goethals from Detroit, Michigan, and I am present.
Thank you, Mark. I am Rick Crammond from St. John, New Brunswick, originally, but from Souk, BC, and I am present.
And I'm Doug from Wollumbar in Australia, and I am present.
And I'm Lee from Okotoks, Alberta, Canada, and I am present.
I'm Ekmar from Germany, and I am present.
I'm pretty sure Guy would say something if he could there, but he can't. Probably doesn't have a microphone to talk or something. But in any case, I think that's good for now. So thanks everybody, and tune into the coming day or two of the Keshe celebration and signing for world peace. And today is Mr. Keshe's birthday as well, so it's really a day to celebrate, and we're all pretty excited. And this is the transition day for planet Earth, and we're going to see all kinds of changes popping up in the next few days and weeks here. So, good times. Okay, enough for now. Thumbs up to you too, Doug, and everybody else. Take care, and see you next week on this channel.